Okay. So screen is clear, right? If you face any issue, please let us know, right? Audio, video, everything is clear. Okay. Shall we start? Okay, fine. Let us start. So if there is any audio issue or video issue, so please let us know immediately. Okay, fine. So look at this question. So given starting compound is alcohol, and look at the reagent, no? SOCl2 in presence of pyridine, that is giving A, and ozonolysis giving B, and NaBH4 is giving C, like sequential reaction is given. So how do we proceed with this? We should know exact idea about reagents first. For any organic reaction, we must know what is the role of that particular reagent. Can you tell me first, no, what is the role of SOCl2? Suppose SOCl2, what is the role of this in organic chemistry? Do you know this? Yes. Alcohol to, yes, alcohol is present or acid is present, so this will convert, suppose there is acid, so this will convert OH group to Cl group. So look at this, there is OH group, right? So this is converted into Cl group in presence of SOCl2. Okay, or if there is direct alcohol ROH, so that will be converted into RCl. So basically any OH group will convert into Cl. What is ozonolysis? O3Zn, no? O3Zn meaning very pure product. Yes, exactly. Because no, in this, the byproducts are like SO2 plus HCl. These two are gases. So this we get very pure alkyl chloride. So this is the best method for converting alcohol to alkyl chloride, because SO2 is gas, HCl is gas. We can easily separate them. So pure compound will get RCl. Fine. Okay. Now tell me, what is O3ZnH2O means? This is called no reductive ozonolysis. We must know all these reagents first. Then we can do the question very simple way. So this is reductive ozonolysis. Okay. So what it will do, it will just break any alkene or alkyne. Okay. But if there is alkene, then what will happen? Aldehydes are ketones based on the structure. Okay. Alkenes to aldehydes or ketones. Depends on the alkene structure, we get these products. NaBH4, what is NaBH4? What is NaBH4? NaBH4 is good reducing agent. Okay, so it is good reducing agent. It donates no H minus. Okay, so alcohol, aldehydes, aldehydes to alcohols or ketones to alcohols. So very common reagent. This is very common reagent. Aldehydes are ketones to alcohols. Okay, so now let us do this question very simple way. So only one OH is there. It will not react with double bond. That's its advantage. Okay, so there is no addition reaction with SOCl2, just substitution. OH will be replaced with Cl. So what is A? So I'll write A. No? So A structure will write this CH2 double bond CH, CH2. Just replace that OH with Cl. That's it. Everything else is same, right? Ozonolysis, they are saying no, after ozonolysis C5H9ClO formula is given. So according to that, so where you break this alkene now, we should break it alkene stage only. So break here. So add oxygen. because reductive ozonolysis with Zn is very simple. Just break alkene, just very simple, no, like simple cake cutting. Just cut into two pieces wherever there is alkene and add oxygen, or like pizza cutting, no? Add sauce like oxygen, as simple as that, no? So ozonolysis is very simple, and O3Zn is very simple. Just cut that alkene part and divide this and add two oxygens. Okay, fine. So this is C5, but left side there is only one carbon. Right side you have no 1, 2, 3, 4, 5 carbons. So this is our B. CHO, CH2, CH2, CH, Cl, CH3. You can check, no? Formula is matching, right? After this, what will happen? S, NaBH4, no? So that will reduce aldehydes are ketones. So where is aldehyde? See, look at this. Here there's aldehyde. So it will reduce only this functional group. So C should be like CH2, OH, CH2, and this is Cl, this is CH3. Done, right? So option, which option is matching? Just check these options. A is not matching, B, C, D. Which one is matching? C, right? Exactly. So option C. Right. Next, see, look at this question. So very good question. And step by step, we have to do this. Wherever, what you should understand is the reagent is acid. Reagent is acid, and this is alcohol. So first step always protonation. What is protonation? Addition of H plus. Sir, where do I add H plus? There are two possibilities, no? This oxygen has lone pair, and this oxygen also has lone pair. But this is symmetrical. You can add anywhere. That doesn't make any difference. Okay. So what we'll do here, add H plus. Okay. See this carefully. One step by step, we have to do this. No? O plus H. I added H plus here. OH. This OH is as it is. Left side I added H plus. Sir, why you added left side only? You can add right side OH also. Yes, no doubt. No? But both are symmetrical. Okay. Yes. Now what I'll do? Next step, very, very important step, formation of intermediate, that is carbocation. So carbocation is formed. Where carbocation is formed? Here. So there's carbocation formation here. And remember this, wherever carbocation is present next to ring, 3-membered, 4-membered, 5-membered, these cases, no, if positive charge, no, carbocation, positive charge, or you can simply write carbocation is present, if it is present adjacent to ring, so definitely ring will expand. Okay, so this ring has to be, there are conditions, no, like 3-membered ring is fine, 4-membered ring, 5-membered ring. Sir, why not 6-membered? 6-membered ring is more stable. Don't do this for 6-membered ring. Okay, so 3, 4, 5 rings. If there is a positive charge next to ring, what will happen here? Ring expansion takes place. What is expansion? You know, expansion means, right? 5-membered becomes 6-membered. 4-membered ring becomes 5. 3-membered ring becomes 4. So that's how, no? That is called ring expansion. Rearrangement, you can say. Yes, carbon atoms will rearrange, and this rearrangement should give them stability. So what you do is, now look at this. This is our 5-membered ring. I'll highlight this. So this is our 5-membered ring. Okay. So now we'll break this one of the bond, and you attach this green carbon to this, these two. Okay, so we are attaching these two carbons. This is how ring expansions. What we are doing here, carbon-carbon bond is broken and new bond is formed between these green carbons. Okay, so what will happen here? There is 5-membered ring. Yes. Okay, and there is also 6-membered ring now. Okay, so write the 6-membered ring because 5 becomes 6, right? Okay, fine. But where is the positive charge? Where did it go? There has to be positive charge, right? So positive charge must be present on this blue color one. See this, because for this blue color one, we are breaking one bond, but no other bond is formed, right? So where is this blue color here? See, I'll highlight here. This is our blue, okay, and this is our green. This is our green. So there must be positive charge here. Okay, and where is that OH? Achha, we forgot OH or what? So where is that OH? This carbon, same carbon, OH must be present. Okay, so there is OH. Correct. So there is OH. Is that right? Or the next carbon? Wait, 1 second. Let me see this. Yes, OH. No, 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 no. Next carbon here. 1 second. I'll rewrite it. Okay. OH group is there, but OH group position, just check this position. Okay. So this should be like this, right? 5-membered ring is fine, but only one ring is common. Only one carbon is common. See, this is how. Only one carbon is common. 1, 2, 3, 4, 5, 6. Okay. And I'll show where are the greens. No, this is green one. This is green. Okay. So this is blue one. Yes, no, there is OH. But positive charge is present here. Okay. Now, what will happen? This will give electrons. H plus will leave. So basically ketone is formed. So look at these steps. Okay, any doubts here? Any doubts? Just check. No, right? Shall we proceed to the next question now? Okay. Yes. Okay, fine. Look at this next question now. So this is also an interesting question. See this. Look at the functional groups present in first compound. What are the functional groups present here? One is ketone, right? One is ketone. So other one is ester. Which is more reactive? Can anybody tell me now? There are two functional groups we can see. Which is more reactive? Ketone or ester? Because both contains that CO group. Yes or no? Right. So now, which one is more reactive? So obviously ketone. So look at the change, no? Look at the next in this sequential reactions. Look at the next product. No? So there is one. Alcohol is reacting, correct? So alcohol is reacting. So what it will give? Alcohol plus that ketone. No? There is a name, right? It's a very important reaction. There's a name, right? So ketone is more reactive, and this ketone position, you can see ketone position, there is two ether linkages on this carbon, red color carbon, there are two ether linkages. So this is called now, as this is formed from ketone, so this is ketol. Okay, so this is ketol. If it is from aldehyde, what we should call is acetol. Ketol means from ketone. Acetol means from aldehyde. Right. So ketone is more reactive than this. So A, two oxygens. Where are two oxygens? This is not correct. No, this is not correct combination. So A must be CH2OH. CH2OH. So I'll tell you one simple trick. No, how to write ketol. So very simple. You write this reactant, double bond O, and there is CO2, CH3. So what you have to do is just remove water. Just remove water and add this. No, yes. So but SH must not be there. No, SH is not correct. Only two OH groups. So A is wrong. This is not correct combination. What about B? Now B and ester. Can sodium borohydride can reduce ester? No, right? NaBH4 cannot reduce ester. What can reduce ester? I'll tell you. No, LiAlH4 can reduce esters and converts into alcohols. So let me give one example. See, RCOOR dash. So what you have to do is just break the bond, add hydrogens. So that is reduction. RCH2OH plus R dash OH. Okay. So now look at this one. This is not, there is no sodium LaAlH4, right? So lithium aluminum hydride is not there. Sodium borohydride, it can't reduce ester. There is no reaction because NaBH4 is weak reducing agent. There is no reaction. Okay. Now, what about the next one? Look at C. What is happening here? Oxidation or reduction? So that is oxidation or reduction. Look at that. CH2OH2 CHO, right? So that must be okay, oxidation, correct? So that is oxidation. So it has to be some oxidizing agent where this is primary alcohol. Remember, no? See, this is primary alcohol and this is aldehyde. So primary alcohol to aldehyde, will KMnO4 do that job? No, right? You know what? KMnO4 is strong oxidizing agent or weak oxidizing agent? KMnO4 is strong oxidizing agent. So this cannot stop with KMnO4. Okay. So with PCC, that does job perfect. No? So B, I told you B should be LiAlH4, but it is not sodium borohydride. So C should be PCC, pyridinium chlorochromate. So that is perfect. One primary alcohols to aldehydes. Okay. So now what about D? Look at D. So what is D option here? D is just, no, they are saying hydrolysis. Is it correct? D is hydrolysis. Is it correct? Yes, no. D is hydrolysis. Exactly. Because on hydrolysis, we'll get again keto from ketol. Okay, this is just a reversible reaction. Okay, so if you add acid and water, so we'll get this back. So D must be hydrolysis. Yes, understood now? Any doubts? So D is H3O plus, that is fine. Next question then. Next question. See, look at this. Just now we discussed about this, no? PCC. 4 moles of PCC reacted to give this one. Maximum number of moles of acetic anhydride consumed by reactant A. Can anybody tell me now? I told you what is the PCC use, no? PCC use, no? Primary alcohols to aldehydes. Yes. Now, what about secondary alcohol if it is present? So that is converted to ketone. Okay. So primary to aldehyde, secondary to ketone. So look at this, no? Look at the product here. Product is given. Okay. So product is given. So now tell me, no, how many alcohols groups are present there? Can you guess now? 4 moles it is given. 4 moles of PCC. 4 moles of PCC is given. So how many should be present? Very easy question, right? How many alcohols? If you know alcohols, then it is very easy. Yes, no, see. Primary alcohols are 2. So aldehydes we are getting. So this is aldehyde. Yes, this is aldehyde. So they must be primary alcohols. Look at this. I'll write it. Okay. So these two positions CH2OH, no? CH2OH. Fine. What about this? No, this is not aldehyde. No, see, this is what ketone. Right, this is ketone. This is ketone. So which one will give ketone? Secondary alcohols, right? Secondary alcohols are this. Right. So how many acetic anhydride molecules will react? This again, no, if you know alcohols, so this is structure of A. Acetic anhydride reacts like this. I'll tell you the trick. No? Acetic anhydride means I'm writing the reaction ROH. If there is any alcohol, AC2O. AC we write in organic chemistry for this group. CH3CO group is present, that is AC. Okay, not air cooler. Okay, so CO CH3 AC2 two times, and there is oxygen. So this will react with alcohol and we lose, no, which group? CH3COOH. So let me write this. Yes. And what will happen? So ROCOCH3, or you can simply write no ROAC. So any alcohol will react and forms AC, means that H is substituted. Alcohol means ROH, right? That H is substituted with AC. Now, how many H will be there here? How many H are there? 1, 2, 3, 4. So 4 hydrogens will be replaced with AC. So how many moles of acetic anhydride? For each alcohol, 1 mole. So 4 alcohols. So 4 moles AC2O required. Is it clear? Done? Okay, so let us move on to the next question then. Okay, next question. See this. See this question. Very simple. Identify the compound, again sequential reaction, but now this time very simple. Cl2H nu. Light is given, means what? Is it substitution or elimination. What happens here? From reactant to X, what should happen? Cl2H nu. Cl2H nu. So H nu free radical. Wherever there is light is given, so you have to think, no, this has to strike your mind. So there must be free radical formation. Yes, free radical substitution can happen. Okay. So what will happen in free radical substitution? This benzylic hydrogens, allylic hydrogens, tertiary hydrogens, no, or allylic hydrogens, benzylic hydrogens, they get replaced. Okay, they get replaced by halogens. If you use chlorine, chlorine will be replaced by, like, chlorine replaced and bromine replaces hydrogen. So CH3 is there. If you write X is, no, one of the hydrogen, let us say, replace, no, CH2 Cl. But this is just H2O, right? H2O, if it is H2O, what it will give? Just substitution. It should give alcohol. It should give alcohol, right? So X is not correct, right? One chlorine is present, alcohol we should get. So what is X now? X is wrong, right? So you have to do multiple substitution. So X must be this. See, C, Cl, Cl, H. So what will happen with the two chlorines? Now, if this undergoes H2 hydrolysis, so two chlorines will be replaced. Okay, C, OH, C, OH, and H. Now, this is called gem diol. Gem diol. Gem means what? You know what is gem means? On same carbon. Okay, on same carbon, two OH groups can't be stable. Do you know the reason? On same carbon, no, two OH groups on same carbon is very unstable. So this will immediately lose water. The reason is very simple. This carbon oxygen two bonds, single bonds here, these are very less energetic compared to one double bond. So system always move towards stability, correct? We know this, right? So instead of forming two single bonds, what carbon will do? Carbon will just form a double bond. That is highly unstable. Okay, highly stable. C double bond O. So that is why gem diol is highly unstable. So this will immediately lose water molecule and form COH. Okay. Any doubts here? No, right? Next question, or one more question is that, yes. So reaction by which benzaldehyde cannot be prepared. You can't get benzaldehyde from one of the options. Can we select those options here? They are named reactions also. There are some named reactions. Okay. So one by one, see this. What is the name of this reaction? Do you know? There's a named reaction. There's a name for this particular reaction. CO plus HCl. Gattermann reaction. Yes or no? Gattermann reaction. Yes, we get benzaldehyde. Direct CO plus HCl. Yes, we get benzaldehyde. What is this? This reagent is actually Clemmensen, but it cannot reduce acid. It reduces aldehydes and ketones. Plus aldehydes or ketone plus aldehyde or ketone. So that gives hydrocarbons. So this is not at all correct, right? Benzaldehyde we don't get. What is this one? This is like chromyl chloride, no? Chromyl chloride hydrolysis. It is just similar to Itard reaction. And this one is Rosenmund. This is Itard chromyl chloride oxidation. Okay, so these names also we should learn. So this is best method also, right? COCl2CHO, best method, just hydrogen we require, it replaces Cl. Okay, got it? Done. So shall we move on to the next question, right? Okay, we'll move on to the next question. See this. So again, sequential reaction here, no? Some test is given. See this, silver mirror is observed. Copper, metals, no? Copper 573 Kelvin, it is formed A compound. Silver mirror is there. And this is OH minus heating. This is giving Y, this is giving Z with this compound. So what are they? First, we should know what is silver mirror. What is silver mirror? Do you know? What is silver mirror? When we'll get that silver mirror? It is very specific for aldehydes, right? Very specific for aldehydes. So this is called tolerance test. Okay, it is tolerance test. Very specific, and it is for tolerance test. So tolerance test is given by what is the compound? Aldehyde, and also any alpha hydroxy ketone, and also like terminal alkynes. So all these functional groups, so they give tolerance test. They give silver mirror. I'll write it, no? So what are the functional groups will give, no? Tolerance test. One is aldehyde. Okay. So one is aldehyde. Aldehyde. Next, alpha hydroxy ketone. Not simple ketone. There must be hydroxy group, OH group present. Okay. Next to ketone. Alpha hydroxy ketone, aldehyde. Next, terminal alkyne. Terminal alkynes. So these, or so one more I'll tell you, like exceptional behavior from one of the acids, no, formic acid. Not any other acid, okay, only formic acid, because formic acid can convert into carbon dioxide. So all these will give silver mirror with this reagent. Okay, means they give positive tolerance test. So you perform this test, very nice. Okay, so now we can clearly see what should be a copper 573 kelvins, no, and it is giving a, that is giving silver mirror test. So you must know what is copper 573 kelvin, copper heating. So copper heating is very simple. Copper heating, I'll explain this. Wherever copper heating is present, so primary alcohols, no, primary alcohols will give aldehydes. Okay, secondary alcohols will give ketone. They oxidize, and this, you know, what is this? The reaction is called dehydrogenation. Dehydrogenation, a simple oxidation. We are removing hydrogen, so that is also indirectly oxidation, right? So dehydrogenation or oxidation will happen with copper heating. Got it? So primary, secondary is fine. What about tertiary? Even tertiary alcohol will react, but they undergo dehydration. Okay, they undergo dehydration. Tertiary alcohols are present, no? So they undergo dehydration, not direct oxidation. Dehydration. So copper heating, fine. Okay, so now can we guess this C2H6O? C2H6O can be primary, secondary, or tertiary alcohol. Very simple, no? So there's one possibility. This only, right? It can't be secondary, only primary. So A must be aldehyde because it gives silver mirror test. Now, what is this Y compound? X is this, no? X is this. X is ethyl alcohol or ethanol, you can write. A is this CH3CH4. So only one option is matching. If you see options, you can eliminate options with A and X only. A and X only. B, option B is matching, correct? Exactly, right? Option B is matching. So what is Y then? You know what is Y? Just think, no? What is Y? But-2-ene means this contains only 2 carbons, right? This contains only 2 carbons, but Y contains but means what? How many carbons? 4 carbons, right? 4 carbons. Okay. Now look at that one. So what type of reactions with 2 carbons it should give? It is giving 5. With 2 carbons, 5. What is that reaction? It is aldehyde. Remember, no? So that is aldehyde. Okay. And which reaction will give from 2 to 4? So that is condensation. Okay, that is condensation. What type of condensation? Very famous, no? Aldol condensation, correct? Aldol condensation will give double number of carbons. 2 carbons, 4, 3 carbons, 6. But alpha hydrogen must be there. So don't forget that. Okay. So we'll be doing, I'll tell you one simple trick. How to do this aldol condensation. Because by looking at the product and reactant, we can easily guess. See, aldol condensation is this with alpha hydrogen. If there is any aldehyde or ketone, so that undergoes aldol. CH3, okay, and COH, right, like this, because we got this acetaldehyde, right, A. And if this undergoes aldol condensation, you add another acetaldehyde, but write as it is, no alpha hydrogens. Okay, you make sure you write alpha hydrogens next to this oxygen. Next to this oxygen. Okay, next to this oxygen. CH3 and CH. Okay, so what you have to do is in aldol condensation again, just removal of water. See how simple it is. Yes or no? Write any aldehyde oxygen first. Okay, and next the same aldehyde you write again. This is what self aldol you can say. Okay, and remove alpha hydrogens. What are alpha hydrogen? This is a functional group. Aldehyde is a functional group. Next carbon is alpha. Okay, yes. So what will happen here? You write the product CH3, no, CH double bond CH, COH. So what is this name, IUPAC name? If you see 1, 2, 3, 4, right? But-2-ene-1-al. Is that they are asking, right? Yes, but-2-ene-1-al. Why we got it, right? So look at the trick again, right? First write aldehyde oxygen, highlight that oxygen, and write the same aldehyde again because it is self-aldol. Alpha hydrogens next to that oxygen. Done. Next, what is this one? Last one, Z is what? This is called semicarbazide. The reagent itself, no, semicarbazide. And the product should be semicarbazone. What you have to do in the product? I'll tell you. This is also very simple. Why we got aldol? Z, no, CH3COH. Okay, and this NH2, NHCO, NH2. So what you have to do is just remove water here. H2O. So what we'll get? CH3, CH, double bond, because as we remove water, no? N, NH, CO, NH2. This is called semicarbazone. We remove water. Understood? So X, Y, Z. So exactly option B is matching. Any doubts in this? Just check. Full question. No, right? So shall we proceed to the next question now? Yes. See the next question. See the next question. See, what is the name of reaction? First, guess the name of reaction. So there's aldehyde again, and 50% KOH. So what is the reaction here? So this is a special name, right? Cannizzaro. You know this? Cannizzaro's reaction. What is Cannizzaro reaction? See, aldol means aldehyde with alpha hydrogens, but Cannizzaro means no, something else, right? So aldehyde without alpha hydrogens. Aldehydes, okay, without alpha. Without alpha. So this will react and forms what? Alcohol plus acid. So this is undergoing simultaneous oxidation and reduction. That is Cannizzaro. So what you have to do is add acid one time, okay? Means add oxygen. See, look at this. So don't change any other functional group. Cl should be as it is. Yes, no. But see, C, H, already O is there. Add oxygen. So this is what oxidation, right? One time oxidation. So, but there's KOH. So don't write OH here because acid reacts with KOH. It forms a salt. O minus plus. This is one product. And the other product is add hydrogens. See, I'm writing this first aldehyde. Now adding hydrogen. Where do add hydrogen? See, look at this. Only this position you add hydrogen. H here, H here. So CH2 OH. So this is our alcohol. This is our acid salt. So aldehyde undergoes oxidation reduction both simultaneously. This is also called no disproportionation reaction, because same carbon undergoes oxidation, simultaneous reduction. Got it right? Option, which option is correct here? Same position, we are not changing, right? So this position with respect to this is 1 3 position, you can say. So positions are same, yes, but CH2OH CO minus. So option C. Correct? No doubts, right? So we'll move on to the next question. See this. Which of the following compounds will be most readily dehydrated? What I'll give is one more condition I'll mention here. This under acidic conditions. Under acid, you add H plus and check which compound readily means more faster. Which compound undergoes dehydration more easily. Which compound can undergo? What we have to check? Basically, what we have to check is carbocation stability. If more stable is a carbocation, more faster the reaction is. So look at this. You'll break this OH, put positive charge. Break this OH, positive charge. Break this OH, positive charge. In A, B, D, what has happened? A, comma, B, comma, D. Options, no? Positive charge. Next to what? CO group. Positive charges next to CO group. So that means what is happening here? If it is next to CO group, CO group role is, no, will it stabilize carbocation or destabilize? Plus charges immediately next to CO group. CO group can't stabilize, no, CO group withdraw electron density. So this will destabilize. CO group, strong minus I, you can say. Okay, that's strong minus I. CO group destabilize carbocation. So A, B, D, so that these three compounds, no, they never want to lose their OH as they become unstable in acidic conditions, right? They'll not lose. But see this one, this is not next to CO group. CO group is far, right? So option C is correct. So relatively, less withdrawing effect. Sir, CO group is present here also. Yes, but look at this, no? It is far. Look at the carbons. 1, 2. 2 carbons far. Understood, right? So more far, less is its effect, no? And more is its stability. So option C. Okay. See this one now. Read the question carefully first. So what is given here? There is a compound. The given compound describes a condensation polymer which can be obtained in two ways. Okay. So one is either treating 3 molecules of acetone with concentrated H2SO4 or passing propyne through red hot tube. So what is that polymer is? A condensation polymer obtained in two ways, either treating 3 molecules of acetone. See, look at this. So this is our acetone. Okay. So 3 molecules of acetone, or you can see this propyne, no? 3 propyne molecules. So what is that polymer? Which of the following? That's name. Just find out the name. Let's see. Sorry. What is the name of this? This polymer name. Nobody knows. This name is important. That's it. There is nothing left. Oh, mesitylene. Mesitylene. Just mesitylene. This is mesitylene. You can either obtain from this or from this. 3 propynes or 3 acetones. It is given in the question itself. Okay. Next question. Okay. This is interesting. See. Ester with molecular formula was treated with excess of methyl magnesium bromide. See. Excess of methyl magnesium bromide, and the complex so formed was treated with H2SO4 to give olefin. What is the meaning of olefin? You know what is olefin means? Olefin means alkene, oil forming actually. Okay. Olefin actually means what? Alkenes, because alkenes are oil forming substances. So that's how the name came. Fine. Next, olefin is B. Ozone is of B. And from the next step also you can understand, right? B gave a ketone. So that means B must be what? No? Alkene. because it is undergoing ozonolysis, and also shows positive iodoform test. So one by one we'll write, no, iodoform test. Which ketone will give, this is ketone they're saying, right? Which ketone will give iodoform test? So this has to be like this, RCO CH3. So then only it will give iodoform test, and this will break so that no, this part by part, no, this part of molecule will convert into iodoform when it is treated with I2 and NaOH, and the other part, so this part will convert into RCOO minus. So ozonous of B is giving something C8H8O, so this has to be present, no, COCH3, 2 carbons are over, right? This has to be present. Now what is the structure of A? They're not asking B, no. They're asking A. So check these options. I told you what is iodoform test, right? So COCH3 must be there after ozonolysis, right? And C9H10O2, that was treated with excess of methyl magnesium bromide. So first, no, what are the options I can eliminate? Can you tell me, no? What are the options I can eliminate? See this. This is ester. It is given, right? A should be ester. So which option I should eliminate? See, option A is it ester? No, right? This is not ester, right? Yes, this is ester. This is ester. This is not ester, right? So A and D you can eliminate easily. Correct, right? Exactly. Now let us do with B. Let us proceed with B. B or C. Any of them are correct answers. But which is correct? We'll verify that. No? CH3, CH2, COO, C6H5. Now, what will happen with methyl magnesium bromide? Is it matching? Number of carbons also you check, no? This is 6, 1, 7 plus 2, 9. And this one, 6, 8, 9. Achha, both are matching. Okay, fine. Then we have to do this. Okay. C2H5, COO, fine. Methyl magnesium bromide excess is used. What we have to do, this methyl part, no, will get added here to this carbon, CO carbon, but excess is given. So this should give tertiary alcohol. Okay, CH3. Okay, so I'll write this CH3, CH2, COH, CH3, CH3. This is tertiary, excess of methyl magnesium bromide. After this, what happened here? What they did, they treated with concentrated H2SO4, no, to give olefin. Alkene it should give. Which alkene will get? Dehydration, right? Dehydration means CH3, CH double bond, CH, CH3, CH3. After this, no, ozonolysis. They did ozonolysis. See this? Ozonolysis B. This is our B, no? This is our A. And ozonolysis, just cut this into two pieces, no? Just like pizza cutting, I told you, right? Very simple ozonolysis. Cut into two pieces, add sauce, and take like that. So this is what left side fraction will get CH3 CHO. Next right side fraction, yes, CH3CO CH3. Ketone is given, no? This will give positive iodoform test. Will it give positive iodoform test? Yes, no doubt, right? This will give. But this is not, no, this is just C3H6O. This ketone, but C3H6O. But see what they have given, C8H8O. So this is not our answer. Only left option is C. Option C should be the answer. Okay, see this carefully and do the same process, because B cannot give, no, because C8H8O is not possible. 6 carbons must be present. So somewhere we will get this. Understood? Clear? Okay. Okay, students, we are done for today. Thank you, everyone. I hope you have learned new reactions, new name reactions, and with clarity, with few tricks. Yes, I hope you like the session. So it's time to end the session today. So thank you so much, Nishant, Isha, Srileka, and Ramnathan, everyone. Thank you. So please share your feedback. Okay. Thank you, everyone. Thank you. Yes, I hope this is the last session of this course. Okay. Thank you, Sarvesha. So all the very best for your future. For future engineers. Okay. So don't forget, make in India. Don't go abroad. Okay. After engineering. So whatever you want to take, no, like some students really like mechanical, or some students really like civil. Okay. So I hope you will achieve your respective branch in respective college. Okay. Yes, yes. And make a very good India. Means we have so many bright students like you, right? Okay, bye. Bye, everyone. Okay. Aerospace, good, good. Computers. Okay, thank you, everyone. So we're ending the session. Okay, bye. Bye. Take care. Stay safe. Okay, bye.